Increase in atmospheric CO2 increases the amount that water can absorb. Cold water will absorb more CO2 than warm water. When oceans cool down, they take in more carbon dioxide from the atmosphere. When they warm up, they expel CO2. That's the reason these curves match so well. The increase or decrease in atmospheric carbon dioxide is determined by water temperature. During the warm period of 135,000 years ago, atmospheric CO2 reached about the same level as that reached during the pre-industrial times, 270 parts per million. This was likely from CO2 being released from water bodies as the waters were warmed by increase in atmospheric temperature. Carbon dioxide was absorbed back into the water as temperatures cooled at the onset of the Ice Age. This brought about decrease in atmospheric CO2 levels to 200 parts per million or less with the coldest temperatures. The early stages of the present warming, which began 13,000 years ago, raised CO2 levels from 200 parts per million to 270 by the 1700s, about the same as the earlier warm period 135,000 years ago. And this is shown by the blue dashed line. The early CO2 rise was likely carbon dioxide being expelled from the ocean. However, with the onset of increased industrial activity beginning in the 1800s, atmospheric CO2 levels have sharply risen to over 360 parts per million at present. This increase was likely due to the burning of fossil fuels. Contrary to environmental theories, temperatures are slightly less than those 135,000 years ago, as shown by the red dashed line, and appear to be cooling further. If carbon dioxide was driving temperatures should have increased about 7 degrees Celsius during the last 2 centuries. Instead, over the long term, there appears to be a decline in temperatures. This next slide will expand this 13,000 year period. Cores from the Greenland Glacier will be used rather than Antarctica, but they show a similar decline in temperature. The upward curves represent increases in temperature, while downward curves represent cooling. And the dashed red line indicates that the temperature trend shows cooling for these 13,000 years. There has been slightly warmer periods approximately every 2,300 years, the latest of which is underway at present.
We've gone from ice ages to warm periods. We had a little ice age until almost the 18th century. We're warming since then, but we're not as warm as it was in the medieval period when you had grape growths in Scotland and so on. So the climate is always fluctuating, and there is nothing in what we have seen in the last 100 years that looks any different from these fluctuations.
In 1979, when the idea of global warming first appeared, the United States launched a satellite which has continually monitored the Earth's temperature. This satellite measures and averages worldwide temperatures over land and water. The upward yellow spikes show the warm periods. The blue spikes show periods of cooling. These temperatures were confirmed by daily weather balloons. The red dashed line shows the temperature trend for these 17 years has been cooling. In contrast, the predicted greenhouse warming by models is in green. Global warming advocates choose to ignore satellite data because it does not agree with their theories. The temperatures which they feed in their computer are from spot readings. These come mostly from cities with very few readings from oceans and sparsely inhabited areas. I think it can be reasonably concluded that the weight of evidence in the geologic record strongly denies that industrial emissions are influencing climate change to any discernible degree. This is especially true of carbon dioxide, which is the principal gas being emitted from the burning of fossil fuels.
The year 2085, the atmospheric level of carbon dioxide has doubled to 540 parts per million. What kind of world have we created?
A better world, a more productive world. Plants are the basis for all productivity on Earth. They're the only organisms that can utilize the sun's energy and create matter, food, and they're going to do that much more effectively, much more efficiently.
A doubling of the CO2 content of the atmosphere will produce a tremendous greening of planet Earth.
Carbon dioxide is the major building block of life. Plants extract it from the atmosphere during photosynthesis and transform it into the food we need to survive. As a byproduct of this process, oxygen is released. Throughout the history of life on Earth, there has generally been much more CO2 in the atmosphere than there is today. These higher levels of carbon dioxide encouraged life. Vegetation in prehistoric eras was lush and grew profusely over wide areas. As this vegetation died and decayed, much of its trapped carbon was transformed into the coal, oil, and natural gas the world depends on today. The carbon dioxide that was in the atmosphere is now being returned to it by the burning of fossil fuels, a natural byproduct of man's industrial evolution. And as more and more scientists are confirming, our world is deficient in carbon dioxide, and a doubling of atmospheric CO2 is very beneficial.
My career has principally been in commercial and academic geologic projects. One of the more interesting projects was a large-scale greenhouse complex in Canada. This is an aerial view of the facility. These huge plastic tents are each larger than a football field. The parking lot at the top gives you an idea of the scale. We grew vegetables year-round in these structures. Nutrients were distributed by a hydroponic system, but more importantly, the atmosphere was controlled. Along with moisture and temperature, we controlled the gases in the atmosphere. And the greatest revelation to me was the effect of carbon dioxide on plants. As we increased levels of carbon dioxide in the atmosphere, plants grew faster and faster. But if we decreased carbon dioxide, growth slowed down until the plant eventually stopped growing altogether. I found that carbon dioxide and sunlight were the most important ingredients to plant growth. As furnaces circulated air continually, CO2 was injected into the airstream to circulate with the air. Carbon dioxide levels were raised to about 1,200 parts per million, which accelerated plant growth as much as 300%. However, if CO2 levels were allowed to drop to 150 parts per million or less, plants ceased to grow altogether. Research scientists in the U.S. Department of Agriculture, as well as many private research groups, have conducted many long-term experiments to determine the effect of atmospheric CO2 levels on plants.
We are investigating the effects of elevated levels of atmospheric carbon dioxide on plants using controlled environment chambers wherein we can control CO2 levels very precisely. We're interested in this because we want to know how C3 crop species such as rice and soybean may respond to future levels of atmospheric carbon dioxide. What we're finding is that these species respond quite nicely to a doubling of carbon dioxide and give increased yields up to 30 to 40%.
With our work with soybeans, we have found that soybean responds favorably to elevated CO2 concentration. The net benefit in grain yield is similar to that for what we're seeing for rice.
Enriched levels of atmospheric carbon dioxide not only enhance plant growth, but they also make plants more water efficient. In fact, a doubling of CO2 would also double most plants' water use efficiency. Plants exposed to higher levels of CO2 do not open the stomates, or pores in the leaves, as widely as when there is less CO2 in the air, and the smaller the openings, the less water is lost by evaporation into the atmosphere. But what does this imply?
As CO2 rises in the atmosphere, we expect more crop production per unit land area and slightly decreased water use per unit land area. So we expect this to lead to overall production with less water requirements. In areas that are irrigated, we expect there to be maybe 40%, at least 40% greater productivity per unit of water applied. And this could lead to either greater areas being irrigated.